A very good morning, dear students. Today in the lesson Measurement and Effects of Heat, we will study about what is meant by specific heat. So let's begin with the specific heat. Now, the specific heat of an object is nothing but amount of heat required to increase the temperature of unit mass of that substance through 1 degree. Now what does this mean? This means that suppose if you take any object and you give some amount of heat, that heat will raise the temperature of that substance through 1 degree. Now here you can see in the picture 1 degree increase has been shown with the red lines. Now that means if the initial temperature of any given substance is, let's suppose it is 30 degrees Celsius. So if 1 degree rise will be 31 degrees Celsius. So to raise that temperature up to 1 degree Celsius, the amount of heat which is required by that particular substance is called as specific heat of that substance. Okay, and how specific heat is represented? Specific heat is represented by the symbol C. Remember, specific heat of any given substance is represented by the symbol small c. Okay, now the unit of this specific heat in SI or SI unit of specific heat is joules per kilogram degree Celsius. Remember, SI unit is joule per kilogram degree Celsius. That you will remember little later when we talk about the amount of heat. Okay, fine. So remember, SI unit is joule per kilogram degree Celsius, and that in Celsius unit is calories per gram degree Celsius. Instead of joules, we are having calorie. Instead of kilogram, we are having gram and degree Celsius. Okay, so remember this. So there are two units. Higher unit is called as SI unit. Lower unit is called as Celsius unit. Like for example, for measuring length, we have higher unit as meter and lower unit as centimeter. So similarly here also we have higher unit of energy is joules and kilograms, and in Celsius unit it is calories and grams. That you have to remember. Now let's suppose some amount of heat is required to raise the temperature 1 degree Celsius, correct? So let that heat, okay, the heat which is shown over here in this figure as the burner is burning here. So that means heat is given, and that amount of heat is given by the letter Q. The heat given to a substance is written by letter Q. M is the mass of the substance. M is the mass of the substance. And temperature, it is 1 degree rise. So that means the lower temperature is taken as initial temperature. The lower temperature is taken as initial temperature, and it is designated by the letter Ti. Okay, it is designated by the letter Ti. That means it has initial temperature Ti. And when it rises its temperature, final temperature, that means when the heat is given, its temperature will start rising. That rising temperature, last final temperature what we are getting, will be calling it as final temperature, and that is designated by the letter Tf. Okay, suppose Q amount of heat is required to raise the temperature of an object of mass M and specific heat C from Ti to Tf, then we have this, then we will have a formula for this. This amount depends on the amount of heat which is required. Okay, you can see the burner there. That amount of heat Q is depends on three things. Okay, depends on how much amount of heat is required to raise the temperature of a given substance from initial to final temperature. It depends on three things. One is mass. Okay, mass of a given substance. Mass can vary and therefore it will depend, amount of heat will depend. Sometimes you may take 1 liter or 1 kilogram, you may take 2 kilograms, anyhow you can take 100 grams, you can take 500 grams. So mass vary, so therefore even the amount of heat required will also vary. Therefore we say that amount of heat which will be given, that will depend on one, mass of the given substance, second, that substance's specific heat. Just now we have learned about what is meant by specific heat. Okay, the specific heat of that particular substance, fine. And increase in temperature, how much increase in temperature you want, how much you want to make it, whether from 30 degree you want to rise it to 70 degree, or from some other number or some other 50 degree, anything. So that temperature range what is there, it also, the amount of heat also depends on it. So accordingly you are going to give the heat. So and therefore we are having the formula for the amount of heat as Q is equal to M into C into delta T. Delta T means final temperature minus initial temperature, because the final temperature will be higher as compared to that of the initial temperature. Therefore, when we are changing, when we are finding out the increase in temperature, we have to always subtract from the higher number to a lower number, that is TF minus Ti. So that will be the formula. So this is the formula to find out how much heat you are going to give to a particular substance to raise its temperature to a given range. So therefore formula becomes M into C into Tf minus Ti. Also in short we call it as delta T. Delta means a symbol will be there, that is triangle symbol, which is called as delta T. Fine. So this is how you can find out the specific heat of a given substance. Different substances have different specific heats. Like for example, here you can see the different pictures. This is the rod of aluminium. Okay. This is what is this? Copper rod. Then we have iron rod. Okay. Then if you see, water also has its particular specific heat. Then gold, mercury, you can see this is mercury, hydrogen molecule, that is gas hydrogen, and even alcohol. All of them have different specific heats. That means the capacity to absorb heat to raise its temperature through 1 degree Celsius will differ in different substances. And here is the table in which you can see the different specific heats of the different substances. Like aluminium specific heat is 0.21 calories per gram degree Celsius. Now you know, you have learned the formula Q is equal to M into C into delta T, where C is the specific heat and these are specific heat. So when you just back calculate, you will get C is equal to Q upon M into delta T. So Q is measured in terms of heat. So Q is heat, therefore it is measured in either joules in SI unit and calories in CGS unit. So it will be calorie upon mass is measured in kilograms and grams. So in SI it will be kilogram and in CGS it will be gram, and delta T is measured in degree Celsius. Therefore specific heat, that is small c, is given by SI units as joules divided by or per kilogram degree Celsius, and CGS will be calories per gram degree Celsius. So you can see in this table the specific heats of different substances. Like aluminium is 0.21, alcohol is 0.58, gold is 0.03, which is very less. That means it gets heated very faster. Hydrogen is 3.42, iron is 0.11, copper is 0.09, and mercury is 0.03. water is 1.0. So here you can see two of them have very less specific heat. So this is regarding the specific heat. Okay, now let's move on to the next part of the lesson, that is called as the calorimeter. Now you have learnt that the temperature of a body or the temperature of any given substance can be measured with the help of a thermometer, right? Then what do we use to measure the heat content of the object? Okay, which device is used to measure the heat content of the object? You have learned for temperature we use thermometer. Then how we can find out how much heat is required, heat is given. So which device is used for that? So for that we use another device called as a calorimeter, which can find out the heat content of the substance. So now let's learn about this device. Okay, so a calorimeter is a device, okay, which is used to measure the heat content of an object, and using this equipment we can measure the heat produced or absorbed. Okay, how much is the heat produced or absorbed by a given substance in a physical or maybe a chemical process. Fine. Then what are the different parts of the calorimeter? If you see over here, you can see different vessels here. There is an inner vessel which is made up of copper. Remember, there is an inner vessel which is made up of copper. Okay, and outside you can see a bigger vessel, and that vessel is called as outer vessel. Okay, so this outer vessel is made up of a substance which is bad conductor of heat. That means heat will neither come get absorbed from outside or neither nor the heat will be going out from inside of the calorimeter. Fine. And in between these two there is a small air cavity. Fine. There is an air cavity which keeps the two vessels away from the heat cannot be passing out from the inner vessel to the outer vessel. Okay, that means the inner vessel is thermally insulated. Okay, it is called as thermally insulated. That means heat cannot go out of the inner vessel since there is an air cavity, as well as the outer vessel is made up of a bad conductor of heat. That means it will not allow any heat to pass out of this inside of the calorimeter. Also, the outer vessel is made up of a lid above, okay, that you can see over here, lid above, which has two holes. Okay, in one of the hole of the lid there is a thermometer which is used to find out how much is the temperature of the given substance, and second is a stirrer which continuously stirs the water to keep the water in the same amount of temperature. Okay, fine. So next is the air cavity, as I've mentioned to you, which keeps the heat not to allow to pass outside. Fine. Then the upper part of the calorimeter is also called as the heat resistant lid, as I mentioned to you. Fine. So these are the parts of the calorimeter, and you can see that it is designed in such a way that it is thermally insulated. Okay, fine. So this is a calorimeter, how it is designed. Fine. Now since it is thermally insulated, what happens is that heat cannot pass out. Now if you see a blue color here, it is nothing but the water. Okay, always remember the inside vessel which is made up of copper, the temperature of this inner vessel and that of the water is always same. Okay, the temperature of the inner vessel and that of the water in it are same. When suppose if you take now any object and heat it, okay, and place that same object inside the water, you will find that this hot object which is there, when you placed inside the calorimeter, there will be exchange of heat taking place. That means the hot object which is there will give away heat and whereas the water inside the calorimeter and the inner vessel will absorb the heat. That means the hot object will lose the heat, and whereas the water and the calorimeter will absorb the heat, and it will go on exchanging this heat to some extent till the temperature of all of these three things, that is the ball inside here which you have seen here, that is the iron ball, okay, temperature of the water as well as the temperature of the calorimeter or the inner vessel becomes same because of the exchange of heat. This exchange of heat is also called as principle of exchange of heat, which you are going to study in standard 10th in detail. Okay, so you see here the hot object, if it is placed inside the calorimeter, it will go on losing its heat, whereas the water and the calorimeter will go on absorbing heat till the temperature of all the three substances become equal. That is, temperature of iron ball is equal to the temperature of the water is equal to temperature of the calorimeter. Similarly, if we put any cold object inside, okay, cold object inside. Now you know that the calorimeter is thermally isolated from the surrounding. Therefore, the total heat lost by before cold object, let us conclude this. The total heat lost by the iron ball will be equal to the total heat absorbed by the water as well as by the calorimeter. Remember, total heat lost by the iron ball is equal to total heat absorbed by the calorimeter and the water inside it. Fine. Now, suppose if we, instead of keeping now the hot object, if we place a cold object inside the calorimeter, then the cold object will receive the heat from the water and that of the calorimeter. Okay, so till all the three of them become equal. So exchange of heat is taking here also, even if the cold object is placed inside. That means its temperature, the ball's temperature is made cool. That means it is frozen and kept inside. It will absorb heat from the water as well as the calorimeter, because water also will have original temperature. So that it will lose, water and calorimeter will be losing, because you have just now learned that the water and calorimeter always have the same temperature. So both of them will be losing the heat and the cold object will be going on absorbing the heat. And in this way here also exchange of heat is taking place. So this exchange of heat will increase the temperature of the cold object and decreases the temperature of the water and the calorimeter. So this is regarding how the exchange of heat is taking place. So let's find out this by using designing one formula for this.